Alright, the multiplication principle, or the fundamental counting principle, just says that if there are any number of tasks, let's consider 2, if there are this many ways to do the first one, and this many ways to do the second one, then we multiply m times n to find the number of ways both tasks could be performed. So let's look at an example of my commute this afternoon to pick up my children. I will leave from Wyndham and head to Pepperell. Alright, now there are 2 ways I could do this. I could stay on 111, or I could take the back roads, so we'll call that Pepperell 2 and Pepperell 1. Now, going from Pepperell to home, in Nashua, there are 3 ways I could go. So that will be home 1, home 2, home 3. So, there are 2 ways that we could figure out how many outcomes are possible. I could list them out, so that stands for P1, H1 would be Route 1 from Pepperell to Pepperell, and then Route 1 home, and then these are all the different options. The other way would be to do a tree diagram. So I start with the first action, and there's 2 options for that, and then there are 3 options for the second action. So, the way this works is the number of n's is how many total options there are. So we listed out all 6. Since there are 6 ends to the branches, and each one of these would be considered a single branch, so that indicates Route 2 to Pepperell and Route 2 to home. 6 ends gives you 6 ways, or 6 outcomes. Here's another little silly example. If I were wearing these ugly pants, I have these 3 shirts, 2 pairs of pants, 3 ties. How many different outfits could I have, regardless of any kind of fashion sense? So I could wear, there's 2 options for that shirt, 2 options for pants for that shirt, and 2 options of pants for this shirt. And then for each pair of pants, there are there are 3 options. For those pairs of pants, there's 3 options for those pants, 3 for those, 3 for that last one, and then another 3 options for each pair of pants. For those pairs of pants. So if I were to actually list them out, it would give me so there's 1, 2, 3 options for the first one, times 2 options for each second choice, times 1, 2, 3, 1, 2, 3, and so forth. 3 options for the last choice. So that's 18 total outfits if I'm disregarding what would actually look good. Alright, last couple quick examples. So there's 3 coin tosses, that's 3 actions, and you get heads or tails. So for each toss, first, second, third action, there's 2 options, and it doesn't matter what you get on the previous action, there's always 2 options. So 2 times 2 times 2 would give you 8 possibilities, or 8 different outcomes. If you're using a tree diagram, you get heads or tails for the first, and then heads or tails for the second, heads or tails for the third option. So there's 1, 2, 3, 4, 5, 6, 7, 8 total branches. So like this branch would be getting heads, tails, heads, which would be different than getting tails, heads, heads, even though you got 1 tail and 2 heads, we're saying the order does matter. So there's 8 different possibilities. For the combination locks, there's the first number, so that would be our first action, our second number, and our third number. So each number choice would be an action. There's 10 possibilities for the first, 10 for the second, 10 for the third, which give us 1,000 total combinations. Here's the homework that we will work on in class tomorrow.